Yeah, there was a question that came in. Aniket, you can also let the other people in. The other people, now
Okay.
that they know that they are late. All right. So, what are some of the things that we're going to be working with, and what does .NET work with, and .NET Core and .NET Framework? How are they different? So, up to version 2.2 of the .NET Core, it only worked with ASP.NET MVC and Web APIs. These are the only applications that were supported earlier. Okay. Later versions of that, version 3 onwards, also supports WinForms and WPF. Okay. So WinForms and WPF are actually a way of working with desktop applications. So the other types, ASP.NET MVC and Web APIs, are for web applications. So version 3 covered that also. Our course covers version 6, which is not 5, but .NET 6. I've made a mistake while typing this out. So this is what we have. And what do we have in our CDAC syllabus? Second. So you need to have Visual Studio 2022 Community Edition, .NET 6, C#, console apps and class libraries, right? ASP.NET Core MVC and Web API. This is the things that we are working with out here in this course, the duration of this course. Okay. And you need to have the software installed before we can actually try this out. Okay, now this is for all those who joined in later, who are not allowed to do that. I'm going to be very strict with the sessions. You need to be here on time. You need to be here at least a couple of minutes before I join in. The session does not start at 2 o'clock and 1 minute. The session starts at 2. You need to be here before the session starts, not after the session starts. So I'm going to say this once, and I'm going to implement it very strictly. So please, everybody follow this. I am jumping in and out of sessions. I'm still coming here on time. I expect you to do the same. All right. Okay, back to the course out here. Now, before we jump into any code, there are a couple of terms that I need you to be associated with, or you to understand, and we'll look at these terms and then take it forward from there. Firstly, you will come across this term quite often. This is managed code, or for that matter, unmanaged code. So let's see what is the difference between managed and unmanaged code. Firstly, all code that you run, which is run by the CLR, so to say, is managed by the CLR, is called as managed code. So all code that we are going to be writing here is going to be managed code. All code is going to be .NET code only, and we'll not be writing any unmanaged code. We'll be writing only all managed code. Unmanaged code, on the other hand, is code that was there before .NET, right? So in certain cases, for backward compatibility, you may need to call some of the older code. And if you want to call some of the older code, such older code that you call, this code before .NET, is referred to as unmanaged code. Examples of unmanaged code are Windows DLLs and COM applications. When you use something called as a Windows DLL, you use a feature called as P-invoke, or this P-invoke is short form for Platform Invoke Services. Right. So that's one example of unmanaged code. The second example, of course, is if you had any COM application that you want to call from .NET, you're allowed to do that. And this is typically referred to as COM interrupt. Right. So these are the two terms that you'll be hearing quite often. When I'll be talking about it later, I'll say that this is managed, this is unmanaged. So then that should be a clear distinction. Are we clear on this, everybody?
Yes, sir.
All right. let's take this further. We saw an assembly. We saw that when you compile your code, you get an assembly. An assembly was a unit of compiled code. So I'm going to go into what is the structure of an assembly. What does an assembly consist of? So there are 4 major elements in an assembly. Let's look at the third one first. MSIL code. So does that ring a bell? What is MSIL?
Microsoft Intermediate Language.
Correct. So firstly, whenever you compile your code, all the code that you have in your assembly is in the IL format. And that's what we're using out here. So obviously code that is there in the assembly is in IL format. So that's one part of it. Secondly, you also have type metadata. I'm going backwards. Type metadata. So think of type as a class. Another word for type you can think of is a class. Okay. There are different types of classes. So all classes are types, but all types are not classes. So we'll see later what are the different types. There are 5 basic types in .NET. Class, interface, delegate, struct, enum. So class is one of the types, but at this point you can just visualize what is the class. What do you understand by the term metadata?
Data about the data.
Right. Okay. So now in my so many years of teaching, I must have asked this question 5 million times. And 5 million times I've got the same response. What is metadata? Data about data. So what data are we talking about here? What data are we talking about here? This is basically information about the class, about the different classes that you have in your assemblies. So things like, for example, the name of the class, right? The access specifier for the class. What are the different members in the class? So for example, let's say if you've written certain methods. So what are the different methods that are there in the class? What are the names of the methods? What are the parameters of the method? What are the return values of the methods? Right? And then you have a lot more other things that you can put into a class. So all this information is being stored in the assembly itself. And we can read this information from the assembly. Right? The assembly can be programmatically, you can read the information. And this programmatically reading information about the assembly is called as reflection. So we can use reflection to find out the metadata of an assembly, details about an assembly. Okay. An assembly also contains the assembly manifest. So the assembly manifest contains details like name of the assembly, version of the assembly, culture of that the assembly is using, strong name for an assembly, list of files contained, references, type reference information, and so on and so forth. So basically all of this is the details or the metadata about the assembly itself. Right? Assembly name and version number are self-explanatory, but culture typically is, when you're creating multilingual assemblies, an assembly can have a culture. Culture consists of 2 parts. One is the language, and the second part here is the country for which you're creating the assembly. So let's say EN-US could be an example of a culture. English in the US, or HI-IN, Hindi India could be an example of a culture, or MR-IN, Marathi India, right? Or FR-France, FR-FR, France in French, so on and so forth. So these are all examples of cultures that you could have. So this would come in handy if you are creating multilingual assemblies. Each assembly that supports a different language would have a different culture. A strong name is something that is used to identify that assembly. Again, we may have time to do this, I'm not sure. But strong name is used to uniquely identify an assembly. Then what are the other list of files that the assembly contains? Any references, any external assemblies that you have that you are referring to in your assembly, right? Any type information, type is another class, any class references that you have. So all of this is information that will be stored in the assembly manifest. Essentially, assembly is now containing what? Information about itself, information about all the classes in there. The code that you're writing is also part of the assembly. And it also contains resources. So resources are typically stored in resource files, and the reference to the resource files is stored out here. For example, maybe you might have strings in there, common strings, or bitmaps, for example, any files, for example, that might be using, any XML files that might be used. So these are all considered as resources to the assembly. So it also contains, resources in there. So essentially, an assembly contains all the details about itself as well. And which is why it's easy to deploy an assembly. One of the problems that we saw with COM, or we talked about with COM, is that one of the problems part of DLL hell was, deployment was an issue. In .NET, deployment becomes very easy because everything that you want to know about the assembly is in the assembly itself. So .NET uses something called as Xcopy deployment, wherein you can just copy an assembly to a different machine, and provided of course that machine has a framework or whatever, and that assembly can be now run on that other machine. You don't need to install it anywhere. You can simply deploy it by copying it. So these are some of the things that go into an assembly, and we are going to try an example on reflection a little later. So not today, of course, but a few days later. And that's where we'll see the assembly a little bit more in detail. All right. So these are a couple of things that I want to talk about. These are things that you need to be aware of, right? And we're going to jump into the code, right? Okay. All right. So a lot of people came in a lot after the session has started. This one will not be allowed next time. One last time I'm warning you, there are about 240 plus right now. So note to everybody, you need to be here before the session starts. You will not be allowed after the session starts. Okay, I hope I'm clear about this, everybody. Okay. You'll have got Visual Studio installed, correct? Okay. Now, it's, for later sessions, it's not going to be practically possible for you to keep up with me and try and code with me at the same time. It doesn't work that way. You will not be able to do either of the two. You'll not be able to see my code also, what is happening, and you'll not be able to code also. Right? So in these sessions, I will not, recommend that you open Visual Studio and try to code at the same time. You'll end up not being able to follow most of the things that I'm trying to do in class. Okay. So my suggestion is keep Visual Studio close, or, if you want to give it a shot, you give it a shot. I have no problem with that. But my advice to you is don't do that. Try and focus on the session. For this session though, for the beginning of this session though, I would like you to open Visual Studio and work with me. Since it's the first time that you are looking at Visual Studio, I would like to just sort of ease you in. So I'll be going very slowly initially, and you can actually keep up with me and code with me also. But I will then, after a point, then I will start going a little quicker. So please open Visual Studio on your machines too. Okay. Now, if it is the first time that you're opening Visual Studio, it will ask you for what settings you want out there. What are the default settings you want? So just choose the default settings and just say, okay, till you come to this screen. If it's the first time that you're starting Visual Studio. If you've done it before, if you've started Visual Studio before, then you would see the same screen that I am seeing. Okay. All right, so I'm waiting for 30 seconds while if somebody is opening Visual Studio for the very first time, then that takes a little longer. All right. Now, once you have come up to this screen, that you see out here with me, it might be slightly different. It may not show you so many options on the left-hand side. Okay. Now, these would be the different projects that you recently worked with. So if you're not opened any project, then this space should be blank right now. Okay. On the right hand side, you will see the same things that I'm seeing, wherein it asks you for what options you want out here. And one of the options there is clone a repository. So if you have some files that you have on GitHub and you want to do a clone on that or whatever, then you can do a clone or a repository. I'm not going to be working with these options. I'm not going to be using GitHub out here at all. So I'll leave that out for now. The second option that you see is open a project or a solution. What I'll be doing at the end of every day is uploading my code to that folder that I shared with you. And you have to download my code and you can open my code and see the code and see how it's working. Now, while doing this, you will need to choose this option of open a project or solution. So when you choose open a project or solution, you can then go to the project that you want to open or the solution, and I'll explain what are the difference, and click on OK and open that thing. Okay, so typically my code, if you want to open, you have to open this. All right, look at the third option very carefully. Open a local folder. Looking at it very carefully, very nicely look at it. Okay, look at it very nicely, because we are not going to use this option at all. Right? We don't want to use this option at all. Look very carefully. Look, whatever you want to look right now only. After today's session, don't even look at it. If it comes in front of you, ignore, turn away. Do not open a local folder. Do not. Open karu naka. Open mat kijiye. Right? Because when you do that, then your code doesn't run the way it is supposed to run. Okay, it will allow you to open it. But while running code, it will start giving all sort of weird problems which you will not know why it's happening. So don't do the third option at all. Our fourth option, of course, we're going to use that right now, which is what? Create a new project. So that's the one that we are going in for. Please select that. So effectively, you're going to use either the second or the fourth option, either create a project or open a project. Now, when you create a new project, again, here on the left-hand side, it shows you the different project types that you have recently worked with. If it's the first time that you're working with this will be shown as blank. Okay. Turn your attention to the right-hand side where there are three drop-down boxes. So select the first drop-down box where it shows you the language that you want to use. So please choose C# as your language, because otherwise the project types are similar and you'll end up then trying to write code in some other language. So make sure that C# is the language of choice. Okay. The next one here is what platform do you want to target? So for example, if you chose Windows, right, then it will show you more of .NET framework applications that will be shown more prominently. So if you choose all platforms, then .NET Core would be also sort of highlighted first, so to say. Okay. Look at the third option. What are the type of project that you're going to work with? So initially, for the first few days, we are only going to work with console applications. So select the console application right here in the third drop-down list box. And unless I tell you, we are not going to change that for the next couple of days at least. Now, when you go in for a console app, you see there are two console apps that you see out here definitely. One is console app, and the second one is console app into bracket .NET framework. So wherever you see that .NET framework, please avoid that. Okay, that would be creating .NET framework based projects. So without anything in brackets is your .NET Core. So we're going in for this option, console app for .NET Core, and choose next. Right. While choosing next, it's asking for the location of where you want to create your project. and whether you want to create a project or a solution or both, or how exactly do you want to work with this. So the middle box out here which says location, please create a folder where all your code is going to be stored. So create it anywhere. Desktop, you can create it on the C drive, D drive, wherever. But create a folder and that's where all your code is going to be saved. Okay, I'm calling this JK for Jammu Kashmir. No. Kharghar, okay. And Jan 23 is what I'm calling this. Okay, so this is where I'm going to create my folder. Now it asks you for the project name and the solution name. So typically you'll be creating your classes. The classes should be created in a .cs file. So you can create multiple such classes, right, in different files. All the classes and all the files that you're creating will be put together into one project. So one project can contain multiple classes. Similarly, you can create multiple projects, right? So, projects that are one project will be one, sort of application, another project will be another application, so on and so forth. And all these projects can be opened in a solution. So effectively, one solution can contain multiple projects. Each project can contain multiple classes, and these classes can be kept in different files. So it's asking for the solution name and the project. The way I'm working, I'll be uploading my files also this way. Every day I'll be creating a new solution. And in the solution, I'll be creating different projects. So for example, my project name, I'm calling this, let's say, class basics. And my solution name, I'm calling it day one. So it's going to create D:training JK Jan 23 / day one / class basics. That's the folders it will create for. All right. Next. It asks you for which version of the framework that you want to install or you want to work with. I have purposely, in fact, removed 7 because a lot of the trainings that I'm doing are in 6. So I don't want it to be sort of creating ambiguity or whatever. Now, if it shows you 7, if it is installed .NET 7 out there, please change that to .NET 6. Right? Whatever we're doing in 6 will work in 7, but whatever features are there in 7 will not work with 6. So I'm going to stick to whatever the CDAC courseware is, which is with .NET 6. All right, there's an option here which says do not use top level statements. Now, this is a feature that I will be covering with you a little later. Okay, so for now, do not select this option. Later, we will see what is a top level statement. All right, so for now, select the checkbox which says what? Do not use top level statements. Right, and click on create. So it takes a couple of seconds to generate the code for you. Actually, just one thing. I asked you to do what? I'm saying do not use top level statements. Please keep that checked. Correct? I'd asked you to do that. And I said, we'll be doing that later. So when I tell you don't do something, what should you actually be doing? I'm telling you don't do that. Huh? What should you actually do? Without telling me, of course.
Nothing.
We won't do, but
no, you're not understanding. I'm saying when I tell you don't do something, your natural curiosity should be, what if I do it? Yes or no? I'm telling you, don't do it. So right now, of course, don't do it. But I'm saying when I tell you don't do it, your first reaction should be, what if I do it? What will happen? Will my machine explode? Right? Or will my machine get formatted? Will will there be an alarm going off? What will happen? So try out a lot of things. My point that I'm making here is I will be doing certain things with you. But when you're coding, when you're trying out stuff, there has to be a natural curiosity in you to try out different things. Sir has said, don't do this. What if I do this? What will happen? What can happen? What will it do behind the scenes? How will it work? What happens now to my code? These are questions that should keep hitting you all the time. So don't do only what I'm asking you to do. Of course, first do what I'm asking you to do. First complete that, because that is the bare minimum that I would expect you to do. But that, I call it a kida. That kida should be there. What if I did this? What if I did that? What if I tried it this way? What if I tried it that way? That should happen. Anyway. So we are here. Our first code is actually shown to you. First program is actually shown to you. What if by mistake you have closed this? So just close this window by mistake. Which window? The program.cs window that you see. Just close this out here, and what if it's not shown to you by any chance? Now, how do you get it back?
Open from file.
So no. You go into the view menu and you choose Solution Explorer. Go into the view menu and choose the Solution Explorer. Now, in the Solution Explorer, what is shown to you out here? First thing right on top, the first line on top, what is it showing you? Solution day 1. That's the name of the solution that we had created. All solutions are saved with an extension of .sln. Okay. So when you want to open the solution from somewhere, you can open the SLN file. That's your solution file. Under the solution, what is it showing you? Under that, what is it showing you? Class basics. Yes. That is your project name. All projects should be opened with the extension of .csproj. csproj for C# project. Okay. Now, under that solution, under that project file, first thing that you see, there are dependencies. So expand on the dependencies. And what you see there are analyzers. Now, analyzers allow you to run code analysis on your code and see what is happening in that code, whether it's code has been written correctly, whether you're writing some code that is unnecessary code, and is it the best possible way of writing it. So analyzers help you do that. We are not going to be seeing code analyzers out here, but you could use code analyzers to run that code to see whether code should be doing what it's supposed to be doing. The second thing that you see there is frameworks. So expand on frameworks, and it shows that this is a Microsoft.NET Core app. Okay, expand on that. If you can expand on that as well, and you'll find that whatever files that you need in here for running your program are all these are assemblies. All these assemblies have been already added for you beforehand. So these are the ones that have been already included by default, and then you can add on more as and when you require them. So we'll see later how to add more assemblies, but these are the ones that have been already selected for you by default. Okay. The file below that, program.cs, was the file that you were seeing some time back. Open that file, please. And what you see here is a namespace, a class, and the main method. Why did the main method get generated? We went in for a console application. When you compile a console application, it will give you a exe. on compilation of a console application is giving you an exe. So exe needs to have an entry point. If you don't have a main in your code, then it would not have, then it will not compile your code. It will give you an error saying that it is missing an entry point. Are we clear on this? Okay. There's already some generated code which is showing you hello world. I'm sure you're curious to try it out. Let's first just run this and see how it's working, and then we'll examine what all have we actually done. So to run your code, you have an option here. Can you see this option on the screen here? There's like a play button here. Okay, like a green play button. So that's one way of running it here. The second way of running it is you could go into the debug menu, and that green play button, the same button is there here. So you could choose this option for start debugging. Or there is also a shortcut key to it. Shortcut key to this is what? Is F5. So you can run it with F5 as well. So either of the three ways, please run your code. And when you run your code, it shows you the output in the console window. So you get your hello world created out there. All right. You press a key and you come back to your code. Are we clear on this so far? Okay. Now let's try and sort of break it down and see what all is this. First of all, you have a namespace created here for you. What name has it taken by default?
Class basic.
What is class basics?
Project name.
Project
File name.
name. Project name. So by default, it is a project name, but it is not important to have the project name. You can give it any name if you want. It doesn't have to be the project name. Okay, it can have any name. The default name shown to you by default was the project name, but it can be a different name if you choose it to be. Okay, that name is not important. So what does the namespace allow you to do out here? A namespace is basically used to organize your classes better. If you had different classes, right, each of which, let's say you got hundreds of classes here. Now, certain classes may be, related to each other, maybe grouped together, and you can put them together by putting those classes into a namespace. It's like saying, supposing if you got, let's say you got 1,000 files on your PC right now. Are all the files at one location? In your case, are you keeping all your files in one place?
No, sir.
No, sir.
You're organizing them in directories, right? So you can think of this like the same thing. Keep, your files which are related together, you put them into one directory. Similarly, classes which are related together, you put them into one namespace. It doesn't create any physical directories. I'm just asking you to logically think about this that way. Now, a namespace might contain classes or other namespaces also in there. So for example, I can have nested namespaces. Namespace, let's say N2, for example. And this again could have other classes in there. Or I could have other class namespaces outside this namespace. Like check this out. If this one is ending here, I'm creating what namespace, let's say N1 out here. Now, what does N1 now again? What can it have? Again, it can have other namespaces or it can have other classes in here. So I could do this also. Let's say N1A, right? Other namespaces. I could have classes in here. Public, let's say class 1, for example, and then whatever I'm not writing any code in the code class. Right? Now, how do I access this class out here? The one that I'm using here, how do I access it from anywhere in my code? So to access it, I would have to give it the namespace name first. So N1 dot N1A dot class 1 is how I could actually access it. So that's what we're doing out here. Are we clear on what is the namespace? Any doubts, any questions? All right. Now, the second thing that you see here is internal class program. So you have, seen access specifiers like public, private, or whatever, but this is probably the first time that you're looking at internal. We'll be looking at access specifiers a little later in the code. So right now, just leave it the way it is. The class program doesn't have to be called class program. It can be called by any name. All right, as long as there is one main function in the class somewhere, the class name doesn't matter out here. It doesn't have to be called class program. That's just the name that it has generated for you. And then you had the static void name. String square brackets args. What is this doing for you? What is it? Any guesses? What is it using out here?
Array of string.
Correct. And when would you use this array of strings? What is it also doing? String args.
Take the inputs from console.
Correct. So if you're using any command line arguments, this is what you could use out here. I don't need it in this example. If you want, you can keep it. You can remove it. And then you come down to console.writeLine. This is what you are given out here. So let's examine the statement a little bit more in detail. This actually is not just console.writeLine. This is actually system.console.writeLine. This is what it actually is. Okay. So let's look at this statement also a little bit more in detail. So what is system? If you look at system, can you tell me by looking at it, what is system?
Class.
Look at it. It's there on the board. You don't need to guess. It's telling you what it is.
Namespace.
Where did you read that? Where did you see that namespace? Look here.
So it's written on the side.
Yeah, it's written right there out here. So you don't need to guess. It's right there in front of you. So system is not a class. System is a namespace. Now, do you see something to the left of system? Do you see the symbol at the left of system? The curly brackets, right? So Visual Studio is a very visual mechanism, right? And it's going to give you a lot of help out here itself. So every time you see system, and if when you see a namespace, you will see what curly brackets there. Curly brackets there indicate that that's a namespace. So by looking at the code itself, you should know what code you have to write. Okay. All right. Now, Visual Studio will keep providing you with this sort of suggestions of your code, what it wants you to do. If you want the suggestion, what is it saying? What is it saying to accept the suggestion? Right? What is it saying? Tab twice, tab to accept it. But what if I don't want to accept it? Like if I start typing this, SY, you can press escape if you don't want what is happening out there. Okay. All right. Now look here for a minute. I'd like you to look here for a second and then I'll give you time to do the same thing. When you start typing your code, I don't want you to type out the code. I don't want you to type out the code. I don't want you to type it out. Why am I asking you not to type out the code? Because when you type out the code, there is always a chance that you might make a mistake. So if I did system dot, why isn't it showing me anything right now?
More or less.
Or for example, what if I had made a spelling mistake? What is going to happen now? Again, not showing you the correct output. What I want you to do is this. As soon as you start typing it, okay, and it shows you that thing, like it's showing you SY system. Do not type out the rest. Instead, now I want to do a system dot console, right? So I'm just typed out SY and look here, I'm pressing a dot. It completes that for me. So don't type out code. Now, what do I need next? I want to use the console class. If I start typing out CO, it shows me that console. How do I know it's a class? How do I know it's written right there, class system.console. It tells you what it is. Can you look at this and identify what are the other classes that you see with system dot? What other classes can you see?
Console cancel event tag.
Right? How did he work on that? How did he know the answer to that?
Symbol, sir. The symbol
Yeah.
on the
Look at the symbol for console. Look at the symbol for console. Everything else that has the same symbol is a class. So even without going there, you should know what it is. Don't be clueless while writing your code. Visual Studio is giving you all the help that you need. It will help you even more than I help you. In fact, you don't need me. If you have Visual Studio, you don't need me. But don't tell that to Dr. Johnson and all the other people out there. Don't tell them. Okay. Tell them, no, we need Vikram sir. It's okay. But secret between us is what? You don't need me actually. Everything that is there in Visual Studio. It's going to give you everything that all the help that you need. Okay. All right. So anyway, system.console. Now here again, what am I going to do? I want a dot right line. So console again, press a dot and it completes that for you. Now the method that it's calling here is right line. So if you start typing out right line, how do you know right line is a method?
return
How do
type
you know?
void.
Yeah. So it
Void
shows
is
you the
method.
signature. It shows you the signature. Void console dot right line with no parameters. What is it showing you? No parameters is one way of doing it, plus 17 overloads. So how many ways can you actually call this code now? In 18 different ways you can call this code. Right? Okay. Can you identify other methods out here? System.console. Can you figure out any?
Position.
Sorry?
The size.
Size, where you see, I'm asking you from here, what do you see on my screen? What are the different methods that you can see?
Beep.
Set Windows position.
Set window
window
size.
Size
Set
and
window size. Okay, size. I missed that. Sorry. And beep, correct. So whenever you see a method, you're going to open parentheses there to call that code. Right? And here in this case, I open the parentheses and then it shows me the different 18 different overloads. You see this here? 18 possible overloads. And then if you scroll through this, you can actually see what the overloads are. So one of the overloads there took a string as a parameter, right? I think 11th one here took a string as a parameter. And then there are different overloads there. So you should be able to know what code to call by reading this. It also gives you 1 or 2 lines explanation of what that is doing. We of course wanted what? Hello world, right? We wanted this hello world. So that's what you're doing. Okay, I'm waiting 10 seconds while you try doing the same thing that I just did.
Sir, how did it show like 17 overloads? Like, may you repeat that?
It
After-
directly when I'm typing it out. System.console.writeline when you did this, or when you were doing the write line, when you just did .w, it shows plus 17 overloads.
Yes, sir. Afterwards, like 17 overloads.
Then I completed with parentheses, and then it shows you the 18 overloads here.
Okay, thank you.
All right, done. Okay, now even though the code that we were supposed to write was system.console.writeline, it also worked with what? It also worked with what? Console.writeline. So why did that work? Even though ideally it should have been what? System.console.writeline. Now don't do what I'm doing. I'm just showing you what I'm doing, but don't do what I'm doing. Don't look on the screen. Don't try to follow me in the code. If I show you what's happening here in the class basics folder, right? There's a bin folder and the obj folder. If I open the obj folder, under obj again, there's a debug folder. Under that, there's .NET 6. And in here, in this folder, there is this one file that is created out here. And the name of the file is project name .global usings. So project name in our case is class basics .global usings.g.cs. And if I open this file for you, okay, so don't open it. I mean, you can just see it at my screen. You'll find that there are certain using statements that it has given out here. One of them is using system. One of them is using system. So what happens here is every time you're writing code, by default, certain using statements are automatically generated for you. Now, one of the usings was what? For system, because of which I'm not forced to write system.console.writeline. Okay. Now I'm going to turn that setting off, and now this you do it with me. Come back to your project. Right click on the project and choose properties. Come back to your Solution Explorer, right click on the project and choose properties. And on the left hand side, you have build. So if you select build over here on the left hand side, on the right hand side, there's an option here which says implicit global usings, which says enable implicit global usings to be declared by the project SDK. So this is the setting that is using those usings that we have given in there. We have not given, project has given. So please deselect this. Deselect this enable implicit global usings. And close the window and come back. Now what do you find?
Hello, sir.
Yes.
Sir, it's not
Sir,
showing.
can you repeat the last step
system.
again?
Right click on this, go into the properties. In the build, on the right hand side, it shows you implicit global usings, which was selected by default initially. I'm asking you to deselect it. Okay, and close this window and come back. Now, when you close the window and come back,
It's not showing options, sir.
That option is not available.
In 2020.
you all might be running the code. Just stop running the code.
Sir, it's inside global using general. Like build package, we have category that's like we have global using, and inside
I'm
that
also using 2022 only, unless you're using some other version. I'm not sure which one is. All right, so I'm going ahead with this. If you can locate it, fine. If you can't, then look out somewhere else. So the moment I've deselected the global usings out there, you'll find that now this line is giving me an error. Console.writeline now is not working. And the reason for that being that the using statements are not being picked up out there. System.console.writeline works, but console.writeline doesn't work. Okay. So now how do you get it to work? To understand why this is working and why this is not working, please try and understand how it works firstly. When you try to say console.writeline, where is it looking for console? The first place it looks is there a class called console? Have you defined a class called console in the same class? So have we done that? Have we given any class called console in the same class? No.
No, sir.
No. Then it says if it's not in the same class, is it in the same namespace or not? So is there a class called console in the same namespace? The answer is no again here.
No.
So if it is not in here, it gives you an error. If it's not, that class is not in the same class or the same namespace, it gives you an error. So now how do you solve the error? This is what you could do. You could go and specify a using statement. I'm saying using system out here. And the way in which it works is if it is not found in the same class or in the same namespace, then it looks out for it in this namespace, which we are given out here. So which is the namespace right now? Using. Earlier, where was it picking up that namespace from? It was picking up from the global settings, which we have deselected. You don't use the global settings. So which is why you have to give it out here. Are we clear on this, everybody?
Yes, sir.
Okay. Now let's look at one more thing. Can I have your attention, please? Everybody look at this again, because it's a very visual thing.
Yes, sir.
Supposing you know that there is a class called console. You know that. But you don't know in which namespace it is. You know that there is something called console, but you're not sure which namespace this exists in. So see what you can do out here. You can move your mouse pointer on this and it shows you a drop down here and it shows you how you can fix it. So one of the options shown out there is what? Using system. So it will generate the using statement for you. And once I select this, it has now added this using system statement. So when you're using these classes, if you don't know what the name of the class is, this is what would help you do that. I'll do that again, once again. It's giving me an error right now. I don't know where that console class is. What do? Move your mouse pointer on that. Select using system. That's the using that it is added on. And now it would work fine. Okay. All right. Now let's try one more thing out here. What if I have a second file in the same project? Right now I have only one file, right? Program.cs. I have only one file. Let me add a second file. So to do that, I'm saying right click, add a class. And I'm adding a class out here. The name of the class is class 1. Okay. So let's say void x, for example. Void x. And in here, I want to do, console.writeLine. Let's say I want to do this. So here, what has happened now? There's a using statement here, so it's actually working because of that. Now, what if I didn't have the using statement? Again, here, what will be the problem? Again, issue is what? What's the issue right now again?
It
What's
will
the problem?
exist for console class and
You
names.
haven't
It can't-
included console class.
Yeah, it can't find that console class. Now we have already given a using in the other line, in the other file. But this, what you're giving, is only available for this file. So what you need to do is you have to repeat it on every file. That is one possibility. The second possibility is instead of giving it in this way, instead of giving it in this manner, you can simply say global using system out here. Now, when you say global using system, it means that this is available for not just this file, but it's available for the entire project. So you don't need to repeat it on every file. And when I come back into this code now this code works fine. So now it's able to pick it up. So that's what your global using statement does to you. Are we clear on this, everybody? This is for the whole project. And this is for what? For the current file. All right. So be aware of both these options. Be aware of explicit, using explicit statement, disable that global using or not. Okay. All right. Any questions, any doubts with this?
No, yes, sir.
Okay. All right. I'm going to try out a few other things here. Now, before we do that,
So
yes.
just can you re-explain the difference between system.console.writeLine and console.writeLine? What difference does it create?
Here, you're explicitly giving the whole path. Now, if you want to avoid using this, the shorter syntax is this. It's doing exactly the same thing. But for doing this, you need to use a using statement on top to say that where is the console class located.
Understood. Understood.
All right. Can I have your attention, please, everybody? Now, I'm going to ask you to create a second class and put a method in the class, and we're going to try calling that method. Now, I don't know whether you do this, okay? I'm asking you all. Do you all, for example, are you all in the habit of doing something like this? Do you all do this? Do you all often do this? Right? Wherein within the same class itself, you create an object of the same class. Do you all do that often? In the same class, you create an object of the same class. Do you all do that often? Are you all in the habit of doing that?
Yes, sir.
Right? Yes. Majority, what? One person has said yes. Others also similar?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Yeah. So this is one habit that I wanted to change. Okay. This is, this is not your fault actually, but this is a bad habit that you have picked up, that you have learned in Java. And when you do this, there's a lot of concepts of yours that get muddled up. So you tend to mix up concepts because of this. So at least when you're in the learning phase, where you're learning about what is happening, this is a very bad thing to do, very bad habit to have. Because you're not sure about what is happening out here, why things work in a certain way or didn't work in a certain way. So I want you to not use this type of code at all. Okay, at least for my module, at least, I mean, you can do whatever you want in Java, but at least for my module, don't do this, because then it is more difficult for you to understand why things work in a certain way or why they don't work in a certain way. So don't do this. Okay. All right. So I'd like you to create other class, and then we'll be creating an object of that class. So in the same namespace, you can do that. You can code that with me. Public class, let's say class 1. Okay. Do this with me, code with this with me, and let's say public void display. Right. So this is a method that I've written in the class. Console.writeLine, whatever, display called, for example. All right. And I want you to help me call this display, which is in the other class. How do I call that display in the other class? What will I need to do? Yes. What will I need to do to call that display? Can I call it?
Extend it.
Sorry. Extend it. Extend the class. Extend means use inheritance. We don't need to import. No. We don't need to import anything. Why are you getting off?
Class 1 dot
Class name
display method.
Class 1 dot method.
Yes, sir.
Nahi re baba, no.
We will have to call it via an object.
And by using
Via
that
an
object.
object.
Yeah, you need to create an object of that class.
Yeah.
So when you do class 1 dot method, it would work if it was a static method. But if it's not a static method, then you need to create an object of the class to call that method. So help me call that method. Help give me the code. First thing, class 1 O. and O is equal to new
New
class 1.
Class 1.
What is O?
Object reference.
Object name reference.
Right? And what is new class 1?
Actual object.
Is an object to the class 1. And what is O doing? O is referring, or O refers to right? So this is things that you told me earlier also. I'm sure you know these options. How can I write the same code in a shorter way? Much shorter way. Class 1 O is equal to
New class.
new class 1, right? This is what you could do. Now, obviously, we're going to write code like this is on line number 23. We're going to write it this way, but now I hope you know what is happening out here. So line 23 is just a shorter way of writing this, and that's exactly what is happening out here. So you're creating a reference which points to an object of that class. So as long as you know the difference between a reference and the actual object itself, I'm fine with you writing this code this way. Achha, now if I want to call that code, how do I do that? O dot display will
the
call that.
method name.
Yeah, we'll call that. Right. And let's try running this. So the display method is called out there. Now, while doing this, you may have noticed when I said O dot, in addition to display, it gave you a few other methods there also. So why is it giving you all the other methods there also? What's the reason for doing that?
Those are inbuilt methods present in object class.
All right. So whenever you create any class, the class inherits from the object class. So this is like saying colon object. Okay, this is understood. All classes inherit from the object class, and the object class has certain methods. So when you create an object of type class 1, you'll find that those methods also are available here. Methods are equals, get hash code, get type, and toString. Those 4 methods are available here. So those are the methods that are actually being shown out. Okay, so far so good. We have created an object of the class and call that. Actually, you'll notice I have just made this as main1 and main. Okay, I've made this as main1 and main. So I have this habit. I don't like to comment out code. So what I'll do is the older code, I'll just call it by some other function name. So I'm calling it main1. Now, if I write one more main, what will happen now? This will be main2, and then there will be another, static void main created out here, for example. Okay. I'll create one more main out here. So that way I'll keep creating more and more mains. I'll keep creating, more and more code. But when you look at my code, you can see what I did first and what I did second. So when you're trying it out on your own, you can see the flow that I'm following out there. Okay. So I won't be commenting out a lot of code. I'll be, making a copy of main, and the older main, I will call it as what? Main1, main2, main3, main4, main5, main6. What is running actually is what is the main function. All right. Any questions, any doubts with this so far?
No, sir.
Okay. So we'll come back to this in a minute. What is overloading a method? What do you mean by overloading a method?
So methods have the same name, but different arguments. Maybe the type
So-
is different or count is different.
So the method having the same name but a different signature. So let's say I'm giving a different signature here, and let me display that S out here. Now to call that method, once you have overloaded that, you could actually call it with o.display, and it shows you one of two variations out here. One is no parameters, and the second one is a string. So whatever. right? You could actually pass the second option out here. And when you run this now, both the methods have been called. The first one, which is the plain display, the second one, which is display with a string as a parameter. So no big deal out there. Okay. What if I had a method like this? Let's say I had public int add. Right, which took int a comma int b, and all it did was I don't know why my cursor is jumping all over the place. Yeah, int a comma int b, and all it did was returned a plus b. Okay, so it generates the code also for me. Now to call the method, of course, I'll need to call it with, let's say, console.writeLine obj.add, and then pass some values to it. Now, what if I want to overload the method so that it can also take up 3 parameters instead of 2? So I want to add 3 integers. One way of doing that would be what? One way of doing that would be what?
Producing a new argument.
We're just saying, int a comma int b comma int c and return what?
A plus b plus
A
c.
plus b plus c. So we just introduce another method, and this again you're overloading the method. And while calling it now, you can call it with what? We can call it with what?
Again,
Either
one integer has to be introduced.
yeah, another either 2 parameters or 3 parameters. So this is one way of doing it. Correct? All right. Now, the same way of doing this, okay, I can do it in an alternate way. So I can achieve overloading in an alternate way. And in this second way, what I'm doing here is I'm using optional parameters with a default value. So what I am allowed to do, of course, is I could say int c is equal to 0. And this would actually allow me to call the code again in the same way. So either can overload the method, one possibility, overload it. Or second possibility, I can also do what? Specify an optional parameter out here. Are they both doing the same thing? From a programmatic, end result point of view, are they both doing the same thing? Yes or no?
Yes, sir.
All are adding it.
Yeah, all are adding it. I'm just asking whether even here also I'm getting what 2 versions of this function. Here also I'm getting what 2 versions of the function. So are they similar now? In the end result, is it similar?
Yes, sir.
Yes. So which would you prefer to use? Would you prefer to use, overloading, or would you prefer to use optional parameters?
Optional parameter.
Why would you say that?
So
Why
while
would you do that?
declaring the method, you can enter the values that you want to add.
That's not the reason why you would want to use that. That's not the reason why you would want to use it. It's lesser code, no? Instead of writing 2 functions, you're writing what? 1 function only. First thing. Second thing is what? It's more maintainable. Supposing I want to make a change in my code, I need to make it only at one place. I don't have to repeat it on all the places. Supposing I told you instead of 3 parameters, it had 10 parameters. So you don't need to write those many functions for working with different options. You can simply give optional parameters and work with this. So optional parameters would be generally preferred compared to what? To overloading a method, right? Even when you're creating it, it makes more sense to have optional parameters rather than overload a method. Agree with this statement? Yes?
Yes, sir.
All right. Now, supposing the code in both these methods were different, then you can't use optional parameters and get the same effect. What if the code was drastically different? Then you can't use that. But wherever possible, your effort should be to try and use optional parameters. All right. Now, let's try out one more feature out here. what if I did this? What if I did this? Why is this code not working? Why is it showing me a compilation error?
So ideally, default value should be that last parameter.
Why? Correct. You're correct. Why? Why?
Because sir, if you pass, the first value will be assigned to the A, and last it will be waiting for the last parameter C if we pass only two value. That's why we.
So imagine this. Now it says what B and C must be passed, but A is optional. Now how do you give B? How do you give B? To give B, what do you need to give? To give the second parameter, what are you forced to give?
First parameter.
First parameter has to be given. So therefore, what you all said was all correct, that it has to be given from right to left. So for example, when you did this, and if you did in C is equal to 0, this is okay. Because it says now first and second must be given, but third may or may not be given. So this is okay. So optional parameters always would be from right to left. Okay, what if I did this? How many different ways can I call this function? How many different ways can I call this function?
0, 1, 2, 3
Four ways.
parameter.
Yeah, total of 4 ways with either 3, 2,
One or no
1
parameter at all.
or 0 parameters. So 4 ways is when I can call that for different function. So I could now call it in this way, what else, what other way? With no parameters, 1 parameter, 2 parameters, or 3 parameters. So I could actually call it in any of these given ways. All right. Acha, now, can I, in this, any of this code, say I want to give only the third parameter. I don't want to give the first two. Can I give only the third parameter here if I want to?
Yes, sir.
How?
Like having comma, and then giving the third parameter.
This is what you're suggesting?
Yes, sir. I think so. It must work.
Sir, instead we can use 0, 0 instead of keeping it blank.
No, I don't want to give 0. I'm
We'll
saying I don't
assign a
want to give a
value.
value. You're saying no, give 0. You're changing my problem statement again, right? You don't tell me instead of this you can give 0. I don't want to give 0. I don't want to give any parameter whatsoever.
Sir,
So this
Java
doesn't work.
prefers left to right preference. I don't think it will.
It won't work.
Doesn't work, right? Doesn't work. This is because this uses a concept called positional parameters. Okay, what we're using here are positional parameters. So what happens in the positional parameter is the first parameter always goes to this 10 always goes where? Always will go where? First parameter here will go to which position?
A.
A.
Left one.
First position. Second parameter will go to the second one.
Second.
Third parameter will go to the third one.
Third position.
So you are depending on what? On the position of this pattern. Right? That's what you're doing out here. Now see what I'm doing out here. See the alternative out here. In this case, I'm saying A colon 10, B colon 20, and C colon 30. Now here, I am not depending upon the name of the parameter, position of the parameter, but I'm also giving the name of the parameters. A and B, A, B, and C are the names of the parameters. And these are called as named parameters. Okay. Why named parameters? Because I'm using the name. So what this allows me to do is something very interesting. I can do this now. C, A, B, let's say. So what are we doing here in this case? The third parameter I'm giving first. Why does the position not matter at all? Why does
Because
the
we are
position not work?
specifying
Because we are
position.
specifying name.
Because we're giving the name.
Yes.
As simple as that. Are we clear on this? So
Yes,
you can do this. Now, because I can do this, see what I'm doing out here? I can also do this. What am I doing out here? What values am I giving here? What
A
values
and
C
B, A and B will be 0, C will be 10.
Correct. So I'm giving a value for C and A and B will take the default value. Can we do this with positional parameters? This last line. Can we
No,
do
sir.
that with positional parameters? No. You can
No,
only
sir.
do that with
Named
name
parameter.
Named
Parameters.
parameter.
Clear on this, everybody? Now, why was this possible? This was possible because it had a default value. What if it didn't have a default value? Will that code work?
No, sir. Compilation error.
So what is the error here now? Why is it not working now? Because A and B must be also given. Why did this code work? Why did this code work? Because I gave all three. Why did this code not work? Because A and B are not optional right now. So how can you get the maximum flexibility? Maximum flexibility you will get with what? With a combination of what and what? With what? Firstly, with
Optional
correct
and
optional
second,
parameters and calling them with named parameters.
named parameter.
So that gives you the maximum flexibility. Clear on this, everybody? Questions, if any? You're going to try out named parameters and play around with it, have fun with it, have fun with your code. What if I did this? What if I did that? What if I did that? So you should be able to work on that. Any questions, any doubts? Yes.
Sir, if suppose we are having two methods and the variables that are declared are the same, like ABC, but the return type is having a different method written
No,
inside.
that is not allowed. That is not.
It will error. Okay.
It will give you a comparison. All right. So what I have here is a situation where I've got one method. What is this method? Do something. It's just printing do something. And I got another method which says do something else. And this prints do something else, for example. Can I call do something else from do something? Can I call the other method from here?
Yes, sir.
Yes, sir.
Okay. All right. So let's try calling this. And then what do you get out here? You get, let's try O dot do something will print you the do something out here. Yes. So look at the last two lines when I'm printing it. The last two lines show you do something and do something else. So both of these are getting called. So no issues there. Okay. Clear on this? This is very simple. No issues there. Okay. Now I'm going to give you one more situation. Let's say there is a variable here, int I equal to 100. Okay. So the variable is a local variable here, declared inside the function. And I want to access that variable in this other method. So I want to print I. Will this work?
No, sir.
So that doesn't work. Why? Because a variable declared in one function cannot be accessed in the other function. Now, what if I want to make it work? What if I want to, a variable that I have here, I want it to be available here. What are the alternatives that you can think of? What else can you think of? How do you make this one available here?
Do something.
During definition, we
and-
have to take integer in around brackets, and we can call it from at line number 77.
Okay. So one possibility is you pass it as a parameter. Any other possibility?
So is it possible to declare it static?
Why static?
Global
You can have it as a
declaration.
class level. You can have it as a class level. So one possibility is you could move it to this class level.
Yes.
and then have both access it. So now it will work. But we are changing the meaning of the variable. Agree?
Yes, sir.
If we are getting this to work, we are changing the meaning of the variable. We are now no longer having a local variable. We are having a class level variable that can be accessed there. So I don't want that. I don't want that. What is the second thing that you suggested? What can we do? Receive this as a parameter. So I could make this work with int I out here. I could do this and then pass that I out here. Correct or no? That was
Yes,
the first option that you all suggested. But in this also, I'm changing the meaning of something. What am I changing the meaning of? What am I changing the meaning of? I'm changing the meaning of this, do something else. No?
Method.
I'm changing the signature now. Agree or no?
Yes, sir.
Yes, sir.
I don't want to do that also.
So in line 77, right line, in that we can call do something dot I.
No, that don't work. That one. That won't work. You can't say method dot variable in. Don't invent syntaxes of your own. Okay, that won't work.
Their object.
No, even if I create an object, how will I access this? You will not be able to access this variable. So now I'm going to show you an alternate way of doing this. See what I'm doing out here. This do something else function, I am moving it here. I'm moving it here. And when I move one function within another function, this function here is called as a local function. Right? Now, where can I call do something else from? I can only call it from within do something. I can't call it from anywhere else. I can call it only from within the same function. Now, when you have a local function, it's giving an error on public void something else. So this here is what is known as, it is implicitly private. What do I mean by implicitly private? It means that it is a private function, but I can't even explicitly give the word private. I can't even say it's private. Are you getting it? The function is what? It is private, but I can't even give the word private. It is internally private. It is automatically taking itself as private. So this is what I mean by implicitly private. Understood? And now you will notice that this is working. What is happening now? The variable I declared here is now available here. So what can local functions do? Local function can what? Access a variable declared in the... Somebody's gone off mute. Could you mute yourself? So local function can access a variable declared in a calling function. So the function that's calling it in the outer function, whatever you want to call it. Okay. You could actually now access it from there. Okay. So this is the differentiator. This is what a local function can do different from a regular function. Right? So first question is, why create a local function? What is the reason for doing that? Very often in your code, as we go along to more and more, advanced topics, very often in your code, you will need this sort of situation. This situation will happen often, that you are calling a function, but the function that you're calling needs to access something that the earlier function has, a local variable declared in that. And one way of solving it, this is not the only way of solving it. One way of solving it is by creating a local function. Are we clear on this, everybody?
Yes, sir. So amending the signature industry-wise is a wrong practice, most preferable or not?
Yeah, so that's what I'm saying. This is being done for a specific job. What is the specific job? What is the specific situation when you will need to create one local function? What did we say? When did you need to create a local function?
When you want to access a local variable.
Declared in the calling code.
Yeah.
Are you getting it? So that is the reason why they have introduced local functions.
Okay.
So I'm also telling you that this situation will come up often in your code. It will happen often that you want to access a function, a variable declared in the other function. And one way of solving it is this. So who asked that question?
Abhishek here, sir.
Abhi, okay. So Abhishek, now when that situation comes up again in future, I'm going to ask the question, what should we do to solve this problem? How can we now access a variable there? And you should quickly come up with an answer of, sir, local function, day one we learned it, that we could do that for you.
Yes, sir.
Right, in the situation that we would encounter coming up.
Yes.
All right. Yeah, any queries, any questions with any of this so far? All right. So I'm almost out of time. Got about a minute or 2 minutes left. I'm not taking up a new topic now. I'm not starting off with a new topic. There's not a lot of lab work that you'll have done for today. So I don't have any assignments for today. Read up on this, read up on .NET, read up on the things that we talked about that we did earlier. Try out these code examples and we will resume tomorrow morning at 8 o'clock sharp. We're going to start with the session, not at 8 o'clock and 10 seconds, not at 8 o'clock and 20 seconds, not at 8 o'clock and 1 minute. So please be here on time. All right. Note to everybody, I will not allow you after the session has started. Session starts at sharp 8. All right. I'll upload the code in the same